Meghna, and today we are here to start the lecture series of the Mathematics 1. In last session, we are discussed about the prerequisite topic of the partial derivative, limit and continuity. Today, we will discuss here the example of the limit. First of all, we recall the definition of the limit. In real world, most of the physical quantity depend on two or more independent variables, and we know the calculus of the single variable as a last lecture. If function is defined R to R, that means domain to codomain, y equal to f of x is a single variable function. We all know about the graph, limit, continuity, derivative and integration of the single variable. Now, we need to extend the basic concept of the calculus single variable to the function of several variables. Function of several variables, especially of 2 or 3 variables, are more interesting because they are related to our three-dimensional system in which we are living. Calculus of function of several variables have great application in the study of fluid dynamics, electricity, probability and many more. Okay, now limit of a function. We say that a function f of xy approaches to the limit L as xy approaches to x0, y0. Then we say that limit xy tends to x0, y0, function f of xy, L is a limit. For every epsilon greater than 0, there exists a corresponding delta greater than 0, such that for all xy, a domain f, we get f of xy minus capital L in modulus less than epsilon whenever modu of xy minus x0, y0 is less than delta. Okay, so this is the definition of limit. Now, property of limit. If we are taking L and M and K are real numbers and applying limit for this case, then K is a constant. Sum of rule. We are taking two limits, then limit of the two function are also added. Difference between two limits, then limit between two limits are differences. For the product rule is satisfied. Okay, if limit is exist for f of xy is L and g of xy is M, then it is also satisfy the product rule of the limit. Now, constant multiple, that means if we are multiplying with the k into L, k into function, then we getting k into L. Similarly, it is also satisfy for the division rule of the algebra as a power rule. If f of xy raised to r of s, then limit raised to r of s, where provided r of s is real number. Okay, so this is the 6 rules of the algebra for the limit of the two variable. Now, to find limit xy tends to x0, y0, f of xy. This is a working rule of the limit. Step 1 is find value of f of xy, x tends to x0 and y tends to y0. Find the limit value of f of xy, y tends to y0, then x tends to x0. If the limit value of f of xy in step 1 and step 2 remain the same, then limit exists, otherwise not. Okay. If f of xy tends to 0, 0, then limit along y equal to mx, mx square, mx cube and so on. If the value of limit does not contain the m, then limit exists. Okay, so this is the working rule of the limit. Now taking the example, first is evaluate the limit xy tends to 3, 4 under root x square plus y square minus 1 upon x plus y. Okay, so what is here x? X goes to 3 and y goes to 4. So, we are replacing value of x and y in the function and we are getting the limit to under root 6, 7. Okay. Limit xy tends to 0 pi by 4. So x tends to 0 and y tends to pi by 4. Okay. So sec 0, 10 pi by 4. What is sec 0? It is 1. 10 pi by 4 also 1. So answer is 1. Now limit x tends to 1 and y tends to 1. But there is a one condition, x is not equal to y. Now we are taking a function x cube minus y cube upon x minus y. What is the expansion of x cube minus y cube? It is x minus y and x square plus xy plus y square and x minus y. Okay, now x minus y and x minus y is cut out. So we have only this function x square plus xy plus y square. So we are putting value of x and y 1 1. We getting answer is 3. Evaluate limit xy tends to 2 0. So here x tends to 2 and y tends to 0. Okay. Now 2xy minus 2 upon 2x minus y minus 4. We are putting value 2x minus y to 2xy whole square minus 2. We are taking a same type of the formation as a numerator in denominator. To set this formation, we are taking a whole square formula. We are converting 2x minus 4 as a whole square term and we get this type of two formations. So, applying the limit, we getting the value is 1 by 4. Evaluate limit xy tends to 0 0 x square raised to 4 upon x raised to 4 plus y square. Now, working rule of the limit, first path is if x tends to 0, then y tends to 0, then we are applying y tends to 0. If x is 0, then 0 0 y square. Y tends to 0, then it is 0. Path 2. First apply y tends to 0, then applying x tends to 0. Then in this case, y tends to 0, so we get x raised to 4 upon x raised to 4. It is 1. Both limit are not equal. So, if we getting two different limit, then limit does not exist. Next example, limit xy tends to 0 0. 2x square y upon x raised to 4 plus y square. Now, path 1. What is path 1? First apply x tends to 0, then apply y tends to 0. If we are applying x tends to 0, then we get 0 upon 0 plus y square. Okay, so it is 0. Path 2. First apply y tends to 0, second apply x tends to 0. Then here y tends to 0, then we get 1 upon x raised to 4 and it is 0. Both are 0. So, we are taking path 3, putting y equal to mx. Then taking limit x tends to 0. If we are putting y equal to mx, then this is a y value, it is also y value, 2x square mx, 2mx cube, x raised to 4 as it is, m square x square, and limit is x tends to 0. Then x square and x square, we are taking a common form of the x square. For numerator, we are taking x square. In denominator, we are taking x square, then x square is cut. So, we are getting 2mx upon x square upon m square. Now, applying 0, we get 0 upon 0 plus m square and it is 0. Okay. Now, putting y equal to mx square because first three path getting a same answer, that is 0. Now, taking y equal to mx square and limit x tends to 0. Okay, y mx square, 2x square mx square, that means we getting 2mx raised to 4, it is x raised to 4, m square, x square raised to 2, that means x raised to 4, and limit is x tends to 0. We are getting a common value, that means x raised to 4 is a common, so we are getting 2m upon 1 plus m square. This is a m term. Here there is no x term in this function. Since the limit depend on m, m is arbitrary constant, limit does not exist. Okay, if in that case we are getting also 0, then we have to check for the mx cube. Okay, so in is this way we getting the limit does not exist. Now, by considering different path of approach, show that the function f of xy has no limit. Here we have to show that function has no limit. Xy tends to 0, 0. So what is our path 1? Path 1 is x tends to 0 and applying y tends to 0. If we are applying first x tends to 0, then we are getting minus y square upon y square. So limit is minus 1. As a path 2, we are applying y tends to 0, x tends to 0, then we are getting x raised to 4 upon x raised to 4. So it is 1. Both are different limit, then we say that limit does not exist as per the definition of limit. Okay. So this is a 7 basic example to do yourself. Okay. Thank you.